Welcome to WizeUp. I'm Paul Arthur, talking today about creation and evolution. How did we get here, right? And also want to talk about dinosaurs. Are they millions of years old, as I think most people presume? Or is it possible that they could be only a few thousand years old? All right, before we dive into that, don't forget to hit subscribe and tell your friends about us. Always appreciate that. Our guest joining us from Washington State, Dr. Mark Armitage. He's the senior microscopist, try saying that 3 times fast, with the Dinosaur Soft Tissue Research Institute. Okay, and that's a mouthful too. Their website, dstri.org. Great to have you with us today, Dr. Mark.
Thanks, Paul, and you pronounced that perfectly. So you're on your way to becoming a microscopist.
Don't count on me doing that again, though. I might not luck out. Well, why don't you tell us a bit about yourself? I understand you're a former evolutionist, actually, as a kid growing up, but now you're a young Earth creationist, and your specialty is in microscopy. So, you know what? Maybe we should ask, first of all, what is that?
A lot of people ask that. Well, I'm a specialist in microscopes. I've had about a 50-year career. Started out with Carl Zeiss, the big German giant microscope. Worked for Olympus and a couple of others. And then I went back into academia, and I finished my master's degree, and I got my doctorate from Liberty University in science education. And then I started teaching in the university system. But a microscopist is a person who knows how to use different techniques with microscopes to look at the various tissues that folks bring to you. I've had people bring me worms and plants and pollen, and one lady walked in one day with jellyfish eyes, if you can believe that, and I had to process those. So I really became a soft tissue expert at the university, learning how to process these tissues so they could be stained, and they could be thin sectioned, and they could be looked at and photographed under all kinds of microscopes. So I've had a long career in that. It's been a lot of fun, and currently we're training students how to do this because there's so many jobs available right now.
Okay, that's fascinating. Yeah, I hear you like working with young people. We'll come back to that later in the interview here, I think. A bit of background here, too. I understand you were a professor at California State University in Northridge, I think it was. And you made a shocking discovery, maybe 2012, 2014, something like that. And you were on a dinosaur dig in Montana. You discovered this Triceratops horn, a great big one, apparently. I think it may have been the largest at the time. And you're on and it had soft tissue in it, right? So everybody's amazed at this. What is soft tissue doing in a dinosaur bone? And what's the significance of that?
Well, exactly right. I was a soft tissue expert, as I explained, and when I started reading the journal papers, I thought, this is impossible, because I recognized how quickly tissues break down if you don't, and even if you preserve them. And formaldehyde, everybody's familiar with that term, and we call it formalin. But even if you preserve it, it decays pretty rapidly. So I had to find out for myself. So I did go to that dig, as you mentioned. We did find that very large 48-inch long Triceratops horn. And when I fractured it open, there was a whole layer of what we call soft fiber or bone in there. It's mostly collagen, but it had cells in it. So I was able to peel that off the bone and thin section it where we showed the cells in it. So it was really a shocking discovery because it wasn't attached to the skull. It was ripped away and on its own, only 2 feet below the surface. So it won me over to the soft tissue paradigm. It's just really shocking. The significance is it really speaks to a young age. We all know that if you put a peanut butter and jelly sandwich in the backyard, that's not going to last very long. Certainly not.
It's not going to be there a million years later.
Yeah.
Now I understand that. You did some more, research on this. You wrote some, papers on this, and you're saying, hey, right, this indicates a young, dinosaur, not millions of years old. Now that probably didn't sit well with some of your superiors, because I understand they fired you because of this. And then you actually had a lawsuit later on, and so to probably everybody's surprise, you actually won that, and they had to pay you for wrongfully dismissing you, right?
They did, and they actually paid out over $2 million because they hired a law firm in Pasadena, a big law firm, and they were on the line for 3 years. So all that taxpayer money went to the lawyers. But actually, I didn't publish any significance in my paper. The only conclusions that I drew were, this is interesting and it must be studied more. But it's obvious. It's obvious to anyone with half a working brain that these kind of things don't last for a long time. And one of the discoveries that we've made recently, which is really shocking, is we're finding living organisms. We found a whole food web of microbes and bacteria and fungi and insects. There's insect remains in these bones, and also living worms. We've actually collected living worms from these bones that are below the surface. So why are
So
they there?
maybe I could jump in there. So what do you mean by living worms? These living worms aren't obviously from 1,000 years ago. So, but there's living worms, but they're looking for food here. Is that what they're doing?
They must be. That's the only reason they capitalize on resources, because there is food in there, and they're also bearing young. We found twice the population of juveniles to adults, and so that means they're reproducing. And so it's crazy. They're called nematodes. They're all over the world. They're known everywhere. But what's funny is they're not as abundant in the soil as they are in the bones that we're collecting. So it's really very shocking.
Okay. How did secular scientists, I guess, respond to this finding? Because again, I mean, no one expects to see soft tissue, millions of years later in a dinosaur, right? So they must have some theories then as to how possibly, potentially, soft tissue could survive that long. Or, of course, I
Yeah.
mean, there's the other side of the possibility, right? Is this actually young?
Well, yeah. How do these tissues get preserved? The story of soft tissue and dinosaur bone actually goes back to the 60s. Dr. Roman Pawlicki in Poland started this whole ball rolling, and then it was forgotten. That's been in the literature, excuse me, since the 60s. But then in the early 2000s, Dr. Mary Schweitzer from the University of North Carolina worked on a T-Rex femur that they pulled out of the ground. And she found stunning examples of beautiful soft tissue because it was encapsulated in this huge femur in the very inside of the bone. We've never really collected large femurs or large complete bones like that. We've worked mostly with shards, and yet they have the same kind of soft tissues in them. So they went looking for a mechanism. What can preserve this over deep time? They wouldn't, of course, accept that they were young because the paradigm is that they're very old. And so they settled upon iron as a preservative. But we know what iron does to bumpers in Detroit in the middle of the winter. So
Well, yeah,
everybody,
does iron preserve? Do we have some sort of a precedent where iron preserves things?
not really. There wasn't any one before. In fact, most of the literature says that naked iron in the human body, I mean, it's encapsulated in the blood, so the hemoglobin holds it together, so it's not exposed to the tissues. But if you just take iron into your system, it'll chew through you like Pac-Man. So no, it's really not a valid mechanism, and so but that's all they have. So the alternative is that these are very young, even in the 10,000 year range or less, and that's
Right.
unacceptable in science.
Well, let me ask: are there any secular scientists that you're aware of who would at least consider the possibility? And of course, if we're going to be scientific, we have to consider all of the possibilities, not just cherry pick here and there, whatever suits our narrative, right? Including us as believers, we need to be scientific, look at all the possibilities. So, are there any out there that are saying, well, maybe Dr. Armitage has a point here? Is there a possibility? Anybody doing that?
Well, it's really cool because we present at secular meetings, and all of our publications are in secular journals. We work mostly through the Microscopy Society of America, but we published in other journals. But there are very few who will say openly that these are young, because if you want your job, if you want to keep your job,
Yeah.
you don't say that. So,
That's
and
not
even
good for science. Sorry, it isn't. If you're worried about losing your job because of different possibilities and ideas you have, that's not
right.
science, is it?
No, it's not. We do have to be open-minded, and there are times that I'm corrected. And one of the reasons we go to secular meetings is because they are going to critically evaluate it and peer review it. And so I've been corrected on a couple of things, and have corrected our presentations based on that. But mostly the relationships that we're building are very collegial and friendly because we don't teach the controversy. We are only interested in the science, the data, and we let people make up their own minds about what they're seeing. But we've really been well received, and it's neat. We've actually been invited to a major university in Texas. We're going December the 1st to work with their equipment because they've got these beautiful labs with $1 million machines that we don't have
Wow.
access to, but they're inviting us now
And
to
that's a
go.
secular university?
Yes, it
Oh
is.
wow, I love it. That's so good to hear. Can I ask about? Okay, so we have again millions of years. I mean, 200 million, 300 million your estimates for some dinosaurs, right? I mean, that's a huge amount of time.
It
How
really is.
accurate is carbon dating? I don't have a clue. So I mean, I'm not sure exactly how it works, but is there any accuracy to this?
Well, carbon dating is a valuable tool, but only for things under 50,000 years because carbon
Under
14.
50,000?
Yes. So, and it can only be done with once living materials. So, wood or animals or plants that are preserved in the fossil record, those can be tested, but not for minerals. For rocks like basalt or anything like that, you have to use another scheme, rubidium, strontium, or uranium to lead. Some of these other schemes that are very complex and where several big assumptions are made in the process. They're kind of fudge factors in the formula that they use. And so it really becomes problematic. But as again, I said, it's the paradigm. You walk into science understanding and accepting that these things are deeply old. And when you think about deep time, I mean, I tell people if you could live for 1,000 years, you'd have to do that 290,000 times through that lifetime in order to do 2.9 million years. So
Oh
it's just
man.
inconceivable. These numbers are inconceivable. And of course, nobody was there to really observe these layers being laid down. But we're finding over and over that these things are young. Even modern animals are buried in proximity to these dinosaurs, and most of them have worms and soft tissue in them. So it really seems like it was one event that laid everything down.
Okay, well, yeah, well, tell us a bit more about what you're actually finding in this soft tissue. Now, I guess, is there like, are there blood cells? I think I saw in one of your interviews you did with somebody else, you were talking about nerves. You found like nerves as well?
Yeah, it's shocking. By the way, there are no red blood cells left that I believe in dinosaur bones. It's a possibility, but the problem is blood clots very quickly, doesn't it? I mean, when you go to give blood in the hospital, they use a tube, a vacutainer that has an acid in there that keeps it from clotting because it's so full of all the clotting factors. So if you
Okay.
cut yourself, bleed out a drop on the countertop and let it sit, it will clot in a very short period of time. So we're not finding red blood cells, but we find vessels that the blood traveled in, and we're finding clotted blood inside those vessels. Because these are bones. They're just like our bones. We have bones. Dinosaurs have bones. And these bones are not rock. They're still bone. Most of what we dig out of the ground is still bone. So the bone cells are there. The vessels and veins and nerve bundles travel together in what they call the neurovascular bundle, and we're finding nerves. We actually compared it to chicken nerves, and they're a direct match. And that paper made the cover of the journal, which we're very excited about. But we've backed
Mm.
away from it because it's pretty controversial, and there's a lot of fibers in the soil that kind of mimic nerves. So we've backed away from that a little bit, but I think we're going to find better examples of nerves as we go along. But that stretchy stuff that maybe you've seen on the Ark in the Darkness film or Is Genesis History, that was pulled right out of the Triceratops horn. It's mostly collagen, just like ours. Ours is really stretchy, but it
Hmm.
had cells in it, and so how can that stuff hang around?
So
And
so this can't be denied, or are there people who might argue that this is contamination of some kind that's showing up?
right, but how do you contaminate a bone with a bone cell? I mean, you'd have to have a bird flying into the mountain, crashing and breaking its wing, and somehow the bone cells crawl out of the wing and crawl through the soil, and they set themselves up in the bone, and they're all in a pattern. They're all lined up in patterns in the bone, and so they'd have to be aligned just perfectly. So how does a cell do that? So the contamination idea is really kind of a red herring. It doesn't work. DNA could be a contamination if we work with it. Microbes could be a contamination. Some people can consider the worms that are in there contamination, but they're going in to find resources and they're bearing young. So that tells us that there is a lot of soft tissue in there.
Okay. And I understand this isn't just a one-off. Okay, we found this amazing Triceratops in Montana, but apparently you're finding these in different locations, different states, different types of dinosaurs, I believe, and you're consistently finding soft tissue, correct?
Correct. So far, we found it in not only the Triceratops, but Torosaurus, which is a type of Triceratops. T-Rex, we're getting cells out of T-Rex, and of course, Dr. Mary found most of the tissues that she's been working with out of T-Rex. What else? Pachycephalosaurus, and there's a few others, but no, it's prevalent in pretty much everything that's dug out. It's got to be subsurface, but even surface specimens. 2 years ago, we published a paper and presented it at one of the meetings where we only worked with surface bones, and they were producing nerves and they were producing cells. So even stuff that's sitting on the surface, for how long, right? That's the question, class. How long have they been there? But even those surface bones are producing these kind of cells.
Okay. Let me ask you, why do you feel, I mean, you're passionate about this, right? Why do you feel it's so important that regular people come to understand that dinosaurs are young and not millions of years old? What difference does that make?
Well, it's several things. First of all, it verifies Scripture. It verifies the account of Genesis or the Great Flood. It makes it a little easier to believe the Great Flood because the Cretaceous layer, which is this layer we dig in, wraps around the entire Earth. So it is completely around the Earth and it's all uplifted. So somehow the Lord worked his magic in the flood and left this layer, which had been buried deeply, up at the surface where we can access it. But number two, if you think about this, the curse for sin was death. God said, you will surely die if you will disobey me. And of course, we die today. People live some longer than others, but not by much. 100, 110 years is about as long as we get. So if the curse was death, and we always had death before the curse, then the curse is invalidated. What else is invalidated? The need for Jesus on the cross. It becomes superfluous. If death has always been here, then what's the big deal about a curse of sin, of death, because of the sin that we commit? So we're literally invalidating the death, burial, and resurrection of Jesus, which saves us if we trust in him, if we believe in deep time. It's really, look at it this way. If you had a good friend and every time you met together, you slapped him across the face before you started talking, how long would your friend hang around you? I mean, and that's literally how we're treating Jesus. We're slapping him in the face because that's his word.
Does the Bible talk about dinosaurs?
It does. In fact, in Job, it mentions two different dinosaurs. And one of the most interesting verses that I have found to be true, when he was bragging, the Lord was bragging to Job about Behemoth, and he said, "Are not their bones like iron?" And they are full of iron. They're full of the iron from the blood that clotted, that is still in the vessels. And that's one reason why I think they're still out there, because the iron is fortifying them from within. So God was right, even when he bragged a little bit about Behemoth to Job. They're full of iron.
Well, it's interesting. Of course, you do hear the different arguments that come up saying, well, if Noah's Ark had two of everything, every species on board, so dinosaurs would be included in there, probably baby ones, right, to fit. But if that's the case, why are they extinct? Or are they? why are they extinct? And what caused them to die? I mean, I'm assuming, the flood would have killed a lot. But again, after the flood, were there dinosaurs?
Well, there quite possibly could have been. I mean, there are legends in various societies around the world where they were fighting dragons. They were being beset by dragons, whatever you want to call those. But and there's drawings. You look at China. China makes stamps. They're postage stamps, and many things are these dragons, which sometimes look amazingly like dinosaurs. And then there's glyphs. There's petroglyphs all around the world. There's a monastery in Thailand, which is in the jungle. It's been overtaken by the jungle, but right there on the relief is a what looks like a stegosaurus with the bony plates across his back. So that's the folklore around the world is full of that. But why did they die? I think the flood changed everything. If there was a vapor canopy or even a hard canopy around the earth in the beginning, because it says he separated the waters above the sky from the waters below the sky. And then he also says that streams came up from the ground and watered the earth. So there was plenty of water in the earth, and still is. There's huge reservoirs of water still inside the mantle of the earth. But that would have changed the climate dramatically. The fossil record shows some organisms that are huge. I mean, dragonflies that are feet long, feet wide.
Yeah, yeah.
That lycopods, some of these ferns are huge in the fossil record, but we don't see them growing today. So the climate has admittedly changed drastically. There's even frozen coral reefs below the ice caps,
Wow.
both poles. So there's plenty of evidence to indicate that it was a very warm, very tropical Earth in the beginning, and all that changed possibly because of the flood. So the other thing
Is there? Oh, sorry. I was just going to say, is there evidence that the flood was global? What evidence is there for that?
there's very strong evidence because, again, this Cretaceous layer, which is quite deep, circumscribes the entire Earth. You can dig for dinosaurs literally on every continent because of this Cretaceous layer. One other thing I need to add, because this is shocking. When we drown in water, if you drown and you're not resuscitated, your blood clots. It's a function of trying to gasp for air and asphyxiating as a result of being underwater. The shock alone can cause you to clot in your blood system. And if you remember the COVID patients, many COVID patients clotted. They're pulling clots out of many of these cadavers now. So we know that you clot when you drown. If you're resuscitated, if you're brought into the ER and you're resuscitated again, then the reaction goes the opposite way because it's a one-way reaction. You either clot completely or you bleed out completely. And so many people who go through near-death experiences in drowning actually die within a week or so of being revived. So we know that clots form, and there are clots throughout these dinosaur bones. We're finding them in every single bone, even back into the Permian, which is supposed to be 290 million years in age. It's still all fully clotted. So again, we think there's great evidence to show that it was global. These fossils are all around the Earth, and there's clots in everything as far back as we can go.
Okay. Well, if you're just joining us, the website is dstri.org. Dr. Mark Armitage, our guest here today. I understand, again, you're passionate about teaching young people about this stuff, and you give away free books on the topic as well for kids, right?
Yes, we do. In fact, we had a fall festival at church a couple Saturdays ago. So we put up a banner, come see T-Rex blood vessels. And we had a lot of kids show up. We had microscopes set up, and they can look through and zoom in and zoom out on the blood vessels. But we gave away 225 books in about 2.5 hours. I think all told, we've probably given away 20,000 books. So it's something we're committed to because we want everyone to understand that this is real. This is science. We're using microscopes and sophisticated equipment to bring this to you and to show you. So we're committed to doing that. We don't sell everything. We give everything away.
Wow.
And we do it
That's
for
amazing.
free.
So how do you function? Is it like a charitable organization people donate to you, or?
We are a 501c3, but we don't even ask for donations. The Lord Jesus just shows up, and we always have plenty of money. And
Wow.
we started this. We bought 40 microscopes, and we went around the country, and we did something like 50 hands-on labs for free around the country. And we'd love to continue doing that. That's pretty expensive, but we built labs now,
Okay.
and students can come here and train. And the
So
cool
you have
thing
a
is,
mini lab basically that you take with you in a truck or whatever, I don't know, and you go to various towns, cities, and do these presentations for a few days and teach people hands-on?
yeah, they're hands-on labs. We set up the microscopes. We bring bones. We also bring the bone juice because we dissolve these bones in a very weak acid, almost like vinegar. And so we take the bone juice with us, and they pipette it out on their slides and cover slip it with a little cover glass and run over to their microscope. And I race them. I say, okay, I'm going to look for a bone cell. And they start racing me, and suddenly hands go up. Got one, got one, got one. So the kids are finding these things on their own.
Well,
But
that's great. That sounds great. So somebody watching right now saying, "Hey, maybe you could come to Canada. Alberta. We got a lot of dinosaurs in Alberta. We're just north of Montana, of course. Yeah. What would somebody? How would somebody get a hold of you to say, could you come to our church?"
get across the Canadian border because getting home with the microscopes, they might impound them. And so,
Oh,
but we can certainly set up labs right across the
okay.
border. Anybody who lives within, say, an hour or 2 hour drive of the border, we can definitely
Yeah,
set up.
yeah. Well, you
It's
know what?
easy.
Montana's a nice place to go for holidays. We went there a couple of years ago, and it was great. So I'm running out of time here. Any 15-second thoughts on this issue here?
Well, just pray for us and pray that people will learn about this. They're still getting the word out is very important. So pray for us. Share our books online. They can be sent around as PDFs. All our published papers are there. So download everything for free and give it away.
I love what you're doing. God bless you guys. Dr. Mark Armitage, our guest today again, Dinosaur Soft Tissue Research Institute and their website, dstri.org. Man, this is, I'd love to see young people get into this and learn some good things here. All right, thanks for watching. Again, don't forget to hit subscribe. Tell your friends about us. If you have any suggestions, Paul at wiseup.ca. And again, you can see all the shows online at wiseup.ca. God bless.